Welcome to Hartman Math. Today we're going to look at operations on polynomials. For that, a couple review problems for our warm-up on some exponent property work. So go ahead and pause the video here, work through problems 1 and 2. All right, number 1, we're going to start with rule to live by number 1. If it's missing an exponent, it gets a 1. So both the 3 and the x. Now we'll distribute the exponent. So we get 3 to the negative second, x to the negative second, y over y to the positive sixth. So then step 3 is the level change. So anything that has a negative exponent will level change. So this is going to go from top to bottom. This is going to go from top to bottom. Since nothing is left on top, we're going to put a 1 on top. And just a reminder that 3 to the second power, since it ended up on the bottom due to our level change, 3 to the second power is 9. All right, number 2, the 4 and the 3 both missing exponents. In truth, this one's not all that critical because it's not in the parentheses. And it's mainly for when it's in the parentheses. But no. Step 2, we're going to distribute the exponent. Only applies to what's in the parentheses. So it's going to go here and here. Does not extend outside, so we're only going to distribute here. So we get 3 to the first, x to the negative third, 4 to the second, x to the 10th. All right, so this is 3, this is 16. We are talking about multiplication, so we can multiply the 3 and the 16. We're going to do a level change here with this one. Since there's no fraction, we assume this is top, it's going to go to the bottom. And now, lastly, do we have more x's on top or more x's on the bottom? How many more? 7 more on top. So we get 48 x to the 7th power, final answer. All right, this is lesson 5.2, operations on polynomials. So we should probably know what a polynomial is. The polynomial function, f of x, is in the form a sub n. So this is just some real number, maybe like 5x to the power of, and this exponent has to be a whole number, plus a sub n minus 1. So the next coefficient, so maybe minus 13x to the, and so on, all the way down until we get to our constant. And the first leading coefficient is not allowed to be 0. The rest of them can be if they need to be. All the exponents are whole numbers, and the coefficients are all real numbers. So, as an example, it might be something like f of x is equal to 7x to the 5th minus 13x to the 4th. And then maybe there's a 0, so maybe there's a gap, and then we get down to plus 3x squared minus 2x plus 11. Something like that. That would be a polynomial function. So it's just some key parts to it. Right here in front, as long as it's written where the highest exponent comes first, okay, that's the leading coefficient. A sub 0 back here, the number by itself that doesn't have an x of any kind that goes with it. A sub 0 is the constant term. And then the highest exponent, n, is the degree of the polynomial function. So if we had one that was 7x to the 5th and so on, and that was the highest exponent, 5 would be the degree. Or we would say it's 5th degree, or degree equals 5. So we're going to start with our operations adding. We're going to do these a couple different ways. We're going to start by adding horizontally, like this. In that case, the parentheses really don't mean anything for us except to say this is our first polynomial, this is our second polynomial, but we don't need them. And then we can just go ahead and start identifying and combining like terms. Like, hey, we got some x to the thirds. So 1x to the third plus 2x to the third makes how many x to the third? Okay. When you add, you do not ever change exponents. We have 3x to the third. Now we're looking for the next highest exponent. 2. This one doesn't have another one with it, so we'll just bring that down. Minus x squared. Next comes the x's. We've got plus 4x and plus 2x. Those are like terms. That makes plus 6x. Again, don't change the exponent when you're adding. Then we've got negative 6 and positive 9. That makes positive 3. That's our sum. That's adding horizontally. Go ahead, pause the video here while you try this one. You don't need the parentheses for addition. No like terms there, no like terms there. We're going to need to combine the negative 4x and the positive 1x and the plus 7 and the negative 2. There's our answer. Example number 2, we're going to take our polynomials, we're going to add them vertically. So we're going to stack one on top of the other and make sure that the like terms go in columns. So we have an x to the third, an x squared, an x to the first. A constant term needs to go in order, so don't mix up the orders. Okay, highest exponent first, then next highest, and so on until we're done. That's how you want to stack them. Then we just add straight down. 6x to the third, negative 5x squared, plus 2x, plus 6. Example number 3, subtracting horizontally. Subtraction, parentheses do mean something. It means something afterwards. So this negative is going to distribute to all of these. You can think of it as adding the opposite. We want to turn it into an addition problem and add the opposite. So it becomes minus 2x cubed plus x squared minus 2x minus 9. The front one is not affected. It works this way. So whatever's after the minus, that's what it distributes to. Now we just combine like terms. We got our x cubed. 1x cubed minus 2x cubed is negative 1x cubed. You wouldn't write the 1. X squared's next. Now x's. Now constant. There's our answer. It's written in standard form, highest exponent first, then next highest, and so on. That's standard form for a polynomial. All right, you try this one, pause the video here, work it through till you got your answer. Okay, let's distribute the minus. So opposite, opposite, opposite. Now we can combine like terms. Don't have one of those. X squared, so we only have one of those. Combine our x's to make negative 5x. Combine our constants to make positive 9. Final answer. Okay. Subtract vertically. This one's a little tricky. As you go through, we do have to do subtraction. Okay? And a lot of times the mistake is forgetting that and doing addition instead. So if we're going to subtract these, it means this polynomial minus all of this. So we're going to go this minus this, negative 2x squared. Okay. But to avoid that, we probably want to, again, change it into an addition problem and just do the opposite of all that stuff. So opposite, opposite, opposite. Now go ahead and add. It's going to eliminate the mistakes that I was referring to earlier. Negative 2x squared minus 8x plus 2. That does bring us to multiplication. So example number 5, we're going to multiply this polynomial times this polynomial, a binomial times a trinomial. So we're going to start with the 2x and distribute it to all 3. So we would get 6x x times x squared is x to the third, because that's a 1 right there. Minus 2x squared plus 8x. And then we're going to distribute the negative 5 to all three of these. So negative 15x squared. Here's where I really like to do the vertical addition. So I'm going to stack the negative 15x squared right underneath this one, so I have an x squared column. And then plus 5x and minus 20. Now it's really easy to add straight down in columns. 6x cubed minus 17x squared plus 13x minus 20. Example number 6, multiply. Here's just another option. You can kind of choose which style you like best. We're going to do this as an area model using the box method. So we're going to set up a rectangle that is essentially 2 units by 3 units. So 2 by 3. So the 4x minus 3 goes here. 4x minus 3 are the terms. And on top where we have the 3, x squared, negative 5x plus 9. So now in each box, we just multiply the row by the column. So 4x times x squared goes here. 4x times negative 5x goes here. 4x times positive 9 goes here. Include the sign. Plus 36x. Negative 3 times x squared goes here. Negative 3 times negative 5x goes here. Negative 3 times positive 9 goes here. And then in this case, the like terms usually occur on diagonals. So we're going to combine these two. We're going to combine these two. So as an answer, we would get 4x cubed minus 23x squared plus 51x minus 27. So at this point, it's really just going to say multiply. So if you want to just do the distributing, that's fine. If you prefer the box method, that's fine. Just go with what makes more sense to you and where you're more successful. So pick the method that you like best. Go ahead and try this one. Pause the video here. All right, this is an interesting one that we're going to come back to later when we try to reverse this multiplication. But you see a lot of these terms end up kind of canceling out, and we would get 8x to the third plus 27. Example number 8, multiply. Okay. Now, our exponent properties don't really apply here. We're not allowed to distribute the exponent because there is subtraction inside. It will not work. Okay. So we need to do what cubing means, which means to multiply x minus 4 by itself again. And we don't have a strategy that allows us to do all of this at one time. So we're going to pick 2 of these, multiply them together. It doesn't really matter. I might pick the last 2 and just multiply these together by one of our strategies. The first 2. Doesn't matter. So x times x times negative 4 times x, negative 4 times negative 4. We haven't touched it this one, so we'll keep it here. I would prefer to go ahead and completely simplify this before multiplying here. We're going to be more successful. So these are like terms, they combine. Now, we have to take this trinomial and multiply by this binomial. We can distribute from the right, so we can multiply x. I like to do it from fewer terms to more terms. It works the other way as well, but it gets a little confusing. So x times x squared, x times negative 8x, x times positive 16. Now we distribute the negative 4 to that, to that, to that. Watch out for your signs. Signs are where most mistakes are going to be made, whether we're talking about positive or negative signs. Add straight down. x cubed minus 12x squared plus 48x minus 64. That's it for today. I'll see you next time.